Well, good morning, everybody. Welcome back to another show. This morning we're out south of Rapid City, about 20 miles, and we're at a private ranch that I've been doing some work on for about 20 years, and have a lot of different things going on with water wells and hydrology and doing different things out here and different projects. And there's 3 wells out here that were drilled by the South Dakota Geological Survey in 2003 for a project we were working on, and today we are out here. We're going to do some piezometer testing or slug testing on a couple of these wells to look at permeability and look at the performance of these wells. So these are in the Minnekahta Formation, and turn the camera around right here, and this ridge right behind us with the trees on it, that is the Minnekahta outcrop, and so that's essentially the recharge area. And here's a well here. This well is 62 feet deep, and the water level in it is about 31 feet below the surface right now. And then the second well we're going to be testing is over the ridge over here, and it's in the Minnekahta as well, but it is 280 feet deep. And so there's a big swell or a fault. In fact, from geophysics, looks like there's a fault running through here and various things. So we're going to test the performance of this. Got some guys from the United States Geological Survey out here today, and they're going to be helping and running the equipment to do the slug test. So stand by.
Obviously, we're interested in measuring the hydraulic conductivity of the aquifer. And what hydraulic conductivity is, it's a property of the aquifer and tells us how well that water can flow through it, specifically groundwater going through it. Normally when we do slug tests, we are doing it in shallower aquifers and with shallower wells. So this is kind of new for us to do a bedrock confined aquifer. And how we do a slug test is we want to displace the water in the well, and then we measure how long that water returns to static. A couple ways you can displace the water in the well. One is through use of a mechanical slug, which we have here. These are, this one here is a 4-foot 1-inch diameter. It's filled with sand and a steel rod in there to weight it down. And we lower this into the well just above the static water level. Then we'll let it go quickly. We'll have a transducer in there to measure the water level, and then that should displace the water up in the well, and then we can measure how long it takes the water to return to static. And then we can pull the slug out of the well, and that will lower the water level, and then it'll return up to static too. So you get kind of 2 slug tests for the price of 1. And the advantage of using a mechanical slug is, just like I have painted on here, you have a known volume of water you're displacing, which helps in your analysis. The second way to do a slug test would be using a water slug, and we have a jug of water here. And you would, the advantage of using a water slug is you prevent cross-contamination if you're doing a bunch of wells. We're going to go ahead and clean this. Colton will go ahead and clean this before we use it. But the disadvantage of using a water slug is you lose a little bit of that initial displacement of the water because the water has to travel down the well and get to the water surface. So the deeper you have to depth of water, the water slug becomes more and more difficult to use. Like Dr. Stetler said, we've got about 30 feet till we get to the water level. So we're right on the edge of where we would want to use a water slug or a mechanical slug. And we're going to give both of them a shot today. So we'll start out by cleaning up our equipment. We use a mixture of Liquinox soap and some tap water. And then we'll program the transducer, hang the transducer, and then get ready for our mechanical slug. We'll give it a few minutes. Again, we're not really sure how quickly it responds. A lot of the slug tests we do respond very quickly. This one is kind of a little bit of a new experience for us. So yeah, a little bit of a mystery, which is the coolest thing about science, is learning about something you don't know about. And then after we do a slug in and a slug out, we'll give a shot with a water slug and see how that is. So take us a few minutes to get set up, and we'll give it a shot. So Colton, if you don't mind decontaminating our large slugs. Colton, what do you think for timing? 1 second. Come on. Say hi. Say hi.
Okay, so this is programming the pressure transducer that is in the little holder right down here on the floorboard, and then with the computer, you set up like what, time between samples and that kind of thing.
Exactly right. And Colton and I just talked about, again, because we're exploring this well, like what interval would be good. And we'll go ahead and start with 1 second. That might be a little bit too aggressive, but the transducer has the memory for it, so shouldn't be a problem. So I'm gonna talk to the transducer here real quick, give a quick look here. I'm gonna change our name for the Dakota Peak, and then I'm going to do a 1 second interval, and we'll go ahead and start it right now.
So you routinely do this, then you program it, you acquire data, then you'll look at it right now, essentially, so you see if it's good and you have it.
Yes, yep. Okay. So, yep, and we'll pull the transducer. Now, the disadvantage of the unvented system is we can't read it in real time. So we're going to have to do our measurements and then pull the transducer and look at the data.
Okay, yeah.
So the advantage, though, of an unvented is I don't need hardly any suspension equipment, so I can keep a very narrow string to hold it, and it doesn't get in the way of the slug and the other water stuff. So
if you get a reputable griffin breeder.
Okay, so this one started, so then we'll start up our barometer.
Because that's what they strive for.
Okay, well, if he's finishing that, I'm gonna take a measurement here, see if we're the same depth to water as we were last week. Oh, you want to be on camera? Huh?
She inevitably will be. She moves fast. You won't be able to keep her out. If I put her back in the pond. You want a drink? Come on.
Oh, there she's on. Kind of hard to see out here in the sun with that light. I think that's a light. Oh, it wasn't. Nope. Let's see, where am I at here? 7 meters. There it is, light came on, and so that sensor down there is hanging in the water. When it comes, hits the water contact, this yellow light will come on. I don't know if you can see that. There, it's off, on, off, on. So right there, and that is, see, 80 centimeters. So 8 meters, 80 centimeters.
Thanks. Okay. So we're putting the transducer a few feet below the water level that we measured. Usually want about 2 or 3 feet minimum. And then we'll tape it off here.
So the transducer's on the end of the tape?
It is on the end of the tape, yep. And the nice thing about this little tape is it kind of stays out of the way of everything. So, and we get a real nice measurement that we've got. The other thing, after we lower the transducer, we need the water level to stabilize for a little bit. So it's always good to wait for a few minutes after you hang it before you do your test.
How much water are we putting in?
Well, we'll let's see. I think we could do the full gallon. What the better thing to do is to actually do a couple trials if our well was working well, and we would use a different volume of water for each trial. And we might have brought, usually I've done for shallower wells, you do like 3 liter trial, a 4 liter trial, maybe back down to a 3-liter trial. So maybe what we could do is start with a gallon, and that way we don't fill up our well either. And we'll do that as our first trial. So.
Okay.
Yeah, she says, you guys go ahead and play with the water. I'm hunting.
I've got my nose working.
So I'm
6.
thinking, or it's 6.
And I don't know, I
It's
don't
not
think I have it
full.
totally full.
No.
Okay.
It's probably got 5 in it, I'm guessing. Like this, Griff.
All right, let's see how much we've let it stabilize for a couple minutes. All right, so Colton will do the first pour here, and again, estimating about a gallon, which or probably about 2 liters out of that. A little bit short.
So you ready?
Yeah. Yep. That's a pretty good slug. Okay. That's good. All right, and then what we can do, we can bring our E-tape again and give it a look and
See if it's
Yeah.
up or down.
Yep.
I need to make one of those for mine.
Yeah, it's a lot easier.
That's handy.
$28.75.
Okay, so we got a 10th increase.
Yeah.
You can haul that tape up.
Okay, good. So at least it's keeping through, apparently.
Yeah.
Just getting through there pretty quick.
So we'll check it again in about another minute. See if we got much of a change. 2 minutes. Oh, that's good news.
28.82.
Okay. We'll give it another 2 minutes. Now, one disadvantage about only putting a little bit of water in there is, of course, you have an annular space between the well casing and the aquifer. And sometimes the disadvantage of a slug test overall is that you might only be measuring the hydraulic conductivity of that little annular space and whatever packing material the driller used between that and the aquifer. So the other good reason to use a big slug or a large water slug is that you make sure that you've pushed water through that annular space and into the aquifer, and then allow the aquifer to return. So ideally, the best way to measure hydraulic conductivity in an aquifer would be through a pumping test. But slug tests are fast, as we're showing. They're easy to do, and you could do a lot of them in one day, and maybe even get relative differences in hydraulic conductivity in your well field or whatever study you're interested in. So they complement it. Just like most things that we do when we collect data, we want to complement with other systems. This would be a great complement for an actual pumping test. All right, Colton, we'll give her another minute, and we'll see, and then maybe we can pull the transducer and see, check out our recovery curve. Yep. All right, let's give it a shot, Cole. And if this recovers, just takes a few minutes to recover, maybe we'll do a little bit larger water slug and go for another test.
28.83.
Okay. Got 100th out of that. So Colton, we'll do one more in 2 minutes, and then we'll be within the accuracy of our instrument for water level recovery. And we'll pull the transducer, take a look, and maybe do another trial.
Okay.
But Dr. Sell, you said there's another well you're interested in too,
Yeah,
right?
just over the rise over here.
You gotta go back all the way around and
No
then
problem.
go over in that field and get up there.
Nice data drive.
So that one is 265 feet or something like that.
Okay.
And again, these are only 2 or 3 feet into the Minnekahta. Is how far they drilled into it and then they stopped. So that's 10 times deeper than this, but the water levels was within like a foot.
Oh.
And it's been steady like that way since we put them in 2003.
And they're under artesian pressure, right?
Yeah.
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 And
Well,
then
that's good.
this one right here in it must have been 20. I can't even remember now. 10 or something like that. There was a really wet year or a really heavy rain or something. And of course, with recharge right there, this thing, you come out here and you pull the cap off, and water just
Really?
flowed out.
Oh.
It was just free flowing.
That'd be so cool.
Yeah.
There's nothing cooler than a flowing
Yeah,
artesian water.
and it was just clean as could be.
Oh, I bet.
And it had a little, it rose up like 3 or 4 inches and had like a little fountain on it, and then the water caps. It was just beautiful. Yeah.
That Tilford well.
Tilford. We get that with
It was
2019.
shooting water.
Oh, yeah.
2019, we got
That was like
Tilford.
40 or 50 feet above the land surface. The thing was
Wow. Yeah.
crazy.
All right, Colton, give her the last one here, I think.
28.85.
Okay.
What was it, a start?
That's 28.85.
85, okay.
Yeah,
Right?
So, yep,
Yeah.
that's what we started at. So
Okay.
let's go ahead and pull
So-
that, and we'll reel up the transfer.
So we have recovery.
Yep. After about 10 minutes, maybe a little less.
Yeah.
You got your stones
Yep.
thing ready.
Give it a 4.
So you're shooting for like a couple gallons, what you're
We're gonna
thinking
do 2
here?
gallons.
I don't think that thing was released.
That'll work. And then we'll do a couple manual measurements and see, watch it change again like we did last time. So. Gotta get H to go. Ellie.
That went up quite a bit.
Come. Come on.
Dogs. I don't want to come. Let them stand out here.
Drop me out, dude.
26.85. It was dropping. It just dropped right after I read that.
Yeah. Well, that's good.
28.65.
26.85.
26.
I mean, I used to do all these things with just a baler,
Oh,
Man, you'd throw that baler in and you'd just be baling back and forth and back and forth. And then that last time I'd just grab it as soon as I saw it and just pull it up and throw it and grab the tape and run the tape in as fast as you can, Man, it was a pain, but that's where the data came from.
So the nice thing about this,
27.01.
we got 2 feet of initial displacement. So having a good
Oh,
initial
okay.
displacement is really good.
Yeah, yeah.
Did you get that, Bill?
I was writing down the time.
27.01 at 9:05.
Oh, she found a snack.
Something. Who knows?
Something interesting.
You want another one?
Yeah, we can wait a minute. It's only been a few seconds, so we'll wait till.
It already dropped by 0.2.
Oh, really?
Yeah.
Recovering a little bit faster
Yeah, it
than
is.
we thought it would. So.
27.38.
Okay.
It's dropping pretty quick.
It is.
All right, we're at the second well here. So we've moved up from on the other side of that pole over there to here. And this well is like 280 feet, 282 feet, something like that. Something like that. To the same formation we were in back there that was only 60 feet below the surface. So this is quite a bit deeper, offset by either a large fold or a mini fault in here. Water levels the same though, about 31 feet below the surface, something like that. So this has 190 some foot water column in it, theoretically, maybe a little more. So we're going to test it out and see. Oh, I got to carry the water, didn't think of that.
Oh, it's no problem. You got her.
So slug test water, we're ready to roll. Dog's happy. Government tape, we can keep using the same piece over and over again.
We do. This one though is starting to.
Let me go get the tape.
Probably about 2 gallons. Hear it sloshing
Yeah, you can
down
hear it
into
slugging
the-
down.
And that's what you usually do with a baler. So you're doing both action. With the
Yeah.
baler, you're putting some pressure on it to try to push through the screen, and then you
Yeah.
pull it back out
Yeah.
through the screen.
Yeah.
For shallow wells, that works pretty good. Yeah, now's a good time.
27.45. 28.08.
Colton, there's a minute.
28.68. 28.68. 28.90.
Okay, well, we're back at the USGS office, just dropping off stuff, and that didn't work out quite as well as we expected. That first well, if you recall, we put the probe down there and found the water level, and then about 2 feet below the water level, the casing was plugged off. It just was a solid, something solid in there. So we went ahead and did the slug test, and the water transmitted through there. And so it must be a rock blockage or something. Probably one of my students in the previous years has dropped a rock in that well and it got lodged down there. So I got to try to fish that out. And then over on the second well, we found the water level, and it was within just a couple of inches of what the other one was. And we sounded it and went down about another 10 feet or so, and it plopped into mud. And so that's just a real kind of a quandary where'd that mud come from, because that well is 260 feet deep, And so if the mud rose up to within 40 feet of the surface, that's 160 feet of mud. And we slugged it, and it took the slug test just like the other well. So there's communication to something, whether the casing is broke or whatnot. So we're going to be investigating that. We're probably going to go out with an air sparger and try to clean that out, and then maybe even image the well and see what we can find in that. So anyway, that's a field day, kind of get you out in the field and look at some fun things. So thanks to the folks who was with me on this, Ron Koth, who I rode out with, and then Bill Eldridge and Colton Medler from the U.S. Geological Survey, who had their instruments out there and measuring the water levels with me today. So that's it for today. Thanks for watching. Hope you enjoyed it. See ya.